Getting the YouTube stream started. Okay. Looks like we're all live. And I don't think there's anything remaining in my Discord. Okay, yeah, just was looking through it quickly. Let's, Zach, thank you. Hey, Stooky. Hope your stream was good, Zach. I'm just debating what I want to do, but, might just do some abstract algebra. Totally unexpected. Yeah, complete surprise. The Doninator. What did I see you doing? Oh, you found that really neat solution for that integral of ln like 1 plus x squared thing. I saw that problem. Oh, Doofenshmirtz, the Doninator. I can't do a Doofenshmirtz voice, but in your plot to control the tri-state area. New Dawn Republic citizens have arrived. Oh yeah. I mean, Phineas and Ferb I was like a little bit too old for to really be into it, but well, at least when it was like coming out, maybe it's still coming out, but I saw a good few episodes. So, hey Scorpra, how are you? So we watched Phineas and Ferb until now. Oh wow, Joseph. It's not. I mean, it's a good show. Group theory, yeah. So, I was traveling over the weekend, and allegedly I read through chapter 5 of this. I may not have been sober for all of that reading though, so I don't know how much of this I'm actually going to remember, but maybe we can just start trying to do problems and seeing exactly how badly I crash and burn. And oh yeah, this symmetric group stuff is symmetric group? Is it called symmetric group? Whatever. Like once I started getting into like the even and odd permutations, I started to lose the plot a bit, but I'm sure it'll be fine. Most basic means that said that characters in the last TV show you watch will save you when in trouble. You haven't been watching Phineas and Ferb. Oh yeah, that's probably one of the best choices. I guess like other than that, like MacGyver or something. Jed, hey, no more withdrawals. What did Pententer assign to do out of this chapter? Okay, 1, 2, 5. Crisis averted. My mind rebels at stagnation. Give me problems, give me work, give me the most obtuse cryptogram or the most intricate analysis, and I am in my own proper atmosphere. I don't mind a little bit of stagnation, personally. Need a balance. Okay, so for number 1, this alpha matrix sends 1 to 2, 2 to 1. If we want to get the inverse of this, if 1 gets sent to 2, wait. I don't know if the book gave like an algorithmic way of doing this, but maybe I can just figure out the logic. I mean, it's really, this is just 2 swaps, all this thing is doing. Like, we can just, isn't this self-inverse? Because 1 gets sent to 2, and 2 gets sent right back to 1. So just... And the same thing with the 4 and the 5 and the 5 and the 4. And the 3 and the 6, they don't change. I guess we could test my theory by composing them. Let's do that, because I'm not at all comfortable with these things, so I want to actually write it out. Wow, why, what? Oh, I know why the glare's changed. I just raised those blinds. Ugh. And I lowered them back down. And that changed how the slats work? Are those things called slats? Probably called slats. Why is my cord is caught on something? Okay, there we go. So... One, two, three, four, five, six. 2, 1, 3, 5, 4, 6. And I'm just gonna make the claim that that is also alpha inverse. But I want to actually compose these and make sure that I'm not crazy. I keep writing A. Two, 1, 3, 5, 4, 6 is alpha, and 1, 2, 3, 4, 5, 6, 2, 1, 3, 5, 4, 6 is alpha inverse, or, you know, you can put them any way you want. But if we give this composed thing a 1, we go from the right, we go to 1, which gives us 2, then we go to the left, that 2 goes back to being a 1. So I think that's what I needed to know, because if we give this thing a 1, we said we get a 1 back out, and that's what we want. If we give this composition a 2, we get a 1, that 1 gets sent right back to 2. Okay, yeah, so this thing is self-inverse. 3, 3, 3, 4, 5, 6. Okay, so alpha is self-inverse. We also need, can we copy down what beta is? One, 2, 3, 4, 5, 6. 6, 1, 2, 4, 3, 5. 6, 1, 2, 4, 3, 5. 6, 1, 2, 4, 3, 5. This one is much trickier. The only thing that's fixed here is 4. We want to compute beta alpha and then alpha beta. So I think there's going to be a trick. Once we get beta alpha, we might be able to do some kind of trick to figure out what alpha beta is. It's not hard to just calculate by hand either, but if we can use the trick that the book used, I think let's use it so we can learn it. First off, beta alpha though, we start with alpha. We give alpha a 1, that gets sent to 2. We give beta that 2, which goes back to 1. Is this... No, beta can't be like a second inverse. That makes no sense. Okay. If we give the composition a 2, the alpha gives us a 1, the beta gives that 1 a 6. 3 goes to 3, 3 goes to 2. 4 goes to 5, 5 goes to 3. 5 goes to 4, 4 goes to 4. 6 goes to 6, 6 goes to 5. Okay. If we want alpha beta now, I think the book did some crazy stuff with saying, like, we'd start with beta alpha and do some sort of like alpha inverse alpha business. And then we'd want to figure out some way to get rid of the alphas on the outside, I guess, but they don't commute. So actually, maybe that's the wrong train of thought. Maybe we want beta inverse somewhere in there. Let me look back what the book did, and if it looks too complicated, we'll just do it by hand like we just did the other one. Oh, is this it? No. Okay, here we go. They go from beta alpha to alpha squared beta. Did you already? Yeah, I'm claiming that alpha was self-inverse. I erased the work already. Not what you were expecting? Um... Oh wait, if these things just aren't equal though, I can never do manipulations to make them equal to each other without doing some extra. Okay, no, I don't think there's any point in trying to do a trick like this. Does a matrix times its inverse equal an identity matrix? If you're talking about linear algebra, yes. They're using matrices here for a completely different purpose. Like in the linear algebra sense, this matrix, I don't think it has an inverse. Or like, you know, the matrices that we're doing don't have inverses. I think it needs to be square to have an inverse. There probably is some linear algebra thing that you can do with these that the book may or may not get into. But the idea of these is is that these represent permutations. Basically, Jed, there might be some crossover, but what this like matrix here means is that given the indices 1, 2, 3, 4 in the top row, if you give this permutation a 1, it outputs the 2. If you give it a 2, it outputs a 3. It's all about like permutations, I guess. And so the matrix form is like a convenient way of I guess showing a permutation, I guess. And so you can also compose permutations, which is what I was just doing with beta alpha. They use gamma sigma here, but this is like the function gamma of sigma of an index. So if you give this composed thing a 1, you go from right. The sigma gives you a 2, but you plug that 2 into the gamma, and you get a 4 for the combined output. Yeah, the inverse undoes that permutation. It assigns the output right back to what the index should be. So alpha is like a pretty simple example. Where it was just its own inverse because it only ever switched pairs of things. But yeah, the identity is considered like they showed an example for 3 things right there. The identity for n equals 3. The first line is always in numeric order. Like, the first line is your input, the second line is your output. Okay. So they're even calling it like, beta of 1 equals 5. Like, this is more of like, these are basically like functions, these things, I guess. In the matrix way, it's just how they show the domain and range. Well, that's probably the input and the output. It's maybe a better word. Yeah. And so they also introduced an alternate notation using parentheses, which seems to have some like theorems about them. Like this matrix alpha here can also be represented with this parentheses. I think disjoint cycle notation. Hey, Paracresol over on YouTube, which grade are you in? I am not currently a student. I graduated with a bachelor's in math 6 years ago. Oh, swap the rows and sort the columns? I don't think the book gave an algorithmic way of finding the inverse like that. That's clever if that works. I kind of want to try it. That would definitely work with the alpha matrix we were given in the problem. What's the beta? Oh, that's a good way of thinking about it. I want to try it with beta now. So we'll swap the rows. I mean, I don't necessarily want to put an equal sign here because I feel like it's bad form, but now if we sort the columns 1, 2, 2, 3, 3, 5, 4, 4, 5. Oh my god, I'm about to write a fraction. 6, 6, 1. Does this undo beta? If we give beta inverse a 1, we get a 2. The 2 goes to a 1. That's a good sign. 2 goes to 3. 3 goes to 2. 3 goes to 5. 5 goes to 3. 4 goes to 4. 4 goes to 4. 5 goes to 6. 6 goes to 5. 6 goes... Wow, yeah, that works. Nice call on that, Jed. Paracresol. Well, I'm currently a high school student. You can see, I mean, that's about all there is to see Paracresol, but welcome in. So yeah, the kind of theme of the streams, I do math homework help, but if there aren't questions around from chat, I'll do my own studying. And so what I have been doing, this is page 135. One thing I've been studying is abstract algebra. If I'm in the mood for it, I also have been doing electricity and magnetism. And so I'm just getting to chapter 5 of this abstract algebra book here. And it talks all about permutations and how they can be represented with like a matrix like this, as well as something called like disjoint cycle form. This is pretty like new stuff for me. Not in my Discord. Hey Ren. Oh, it's been a pretty good book so far. In Penn Center's Discord, Jed, and there's a reading group channel, which if you don't see it, you might need a role. I feel like Penn Center unlocked it for everyone though. But in that channel, check the pins. And it's right there at the bottom. Oh, and Crystal, I dual stream to Twitch and YouTube at the same time. So that's what the chat is up at the top of the screen there. And on YouTube, I'm not really aware of a very big math community. On Twitch, there isn't like a big one either, but on Twitch we have a little like niche of like math streams. So if you're interested in more things like this, or even like similar but like about math with a different style, let me know and I can send you a bunch of links for streamers who stream about math. In the meantime, let's look for alpha beta. And we'll just do it by hand. Okay, so if we give beta a 1, we get a 6, the 6 goes to 6. Give beta a 2, we get a 1, the 1 goes to a 2. Give beta a 3, we get a 2. No, wrong. Oh, actually, okay, we still 3, 2. 2 goes to 1. 4 goes to 4, 4 goes to 5. 5 goes to 3, 3 goes to 3. 6 goes to 5, 5 goes to 4. Okay, good. Not too shabby. Pin center assigned 2 as well. What's up, Jed? It's a smudge on my glasses. I might have screwed up and looked at beta alpha. 1 goes to 6, 6, no? 2 goes to 2. Oh wait, I was thinking of the wrong one. 2 goes to 1, 1 goes to 2. I think that's okay. If we're doing alpha beta and we give alpha beta a 2, the 2 first goes into beta, which gives us a 1. That 1 then gets sent to alpha, which gives us back a 2. But like because it's like function composition, you start with the inside. Yeah. Just like if you had f of g of x or something. Exactly, yeah. Okay, so now we're getting into, with number 2, we're getting into cycle notation. You're late to quit, no worries. So yeah, this question is talking about the other type of notation here. Yeah, Jed, like this is really, once you know what the notation is, like this stuff is really not that bad. The book gets into some more theorems and stuff that I don't quite understand towards the end of chapter 5. But at least for these earlier problems that are computational, it's really not so bad. Oh god, they give us n equals 8 here. Finite state machines. Oh yeah, that's a good like metaphor. I bet you that there's some kind of representation for those here. 2, 3, 4, 5, 1, 7, 8, 6. 2, 3, 4, 5, 1, 7, 8, 6. 2, 3, 4, 5, 1, 7, 8, 6? I feel like I'm doing that memory test. Okay. Where each time it gives you a number with one more digit. See if I can do it twice in a row. 1387 6524. 1387 6524. 1387 6524. Oh, twice in a row. Give me TTS ability, I'll read it to you. Oh, I really hate the TTS, like most TTS voices. They're kind of annoying. I just the ones that are like overly like robot-y. That's a terrible alpha, by the way. That's a second equally terrible alpha. It's a marginally better alpha. Okay. So alpha beta 1 1 1 2 2 3 3 4 3 8 8 6 7 8 6 7 5 1 2 3 4 5. We don't have any repeats, so I'm taking that as it's impossible to have done anything wrong there. You like Brian well enough? Fair, but I don't know. There's always been like a push and pull for me for have evil Talos in the voice. I've also like always been kind of conflicted about how many just sounds I want on my stream, because I feel like there's already like a lot of sounds happening, and when I watch streams I usually prefer the ones with less sounds, but if they're done right I don't mind them, I guess. Okay, so we need to write all three of these as products of disjoint cycles for part A. So alpha, I guess we're gonna start with 1. 1 gets sent to 2. 2 gets sent to 3. 3 gets sent to 4. 4 gets sent to 5. 5 gets sent to 1. That's the end of that disjoint cycle. Then we go on to 6, which goes to 7, which goes to 8, which goes back to 6. Oh. Okay, well that looks nice when you like have it written out like that. For beta, 1 gets sent to 1. That's just so we can omit 1 because it's just a single unit. I don't know why I erased that. 2 gets sent to 3. 3 gets sent to 8. 8 gets sent to 4. 4 gets sent to 7. 7 gets sent to 2. That's the end of that cycle. We need to route 5 and 6. That's all. Oh my god. I think that's considered a 12 watch streak. A 7 watch streak and a 5 watch streak. Wow, thank you. Technically, yes, Jed. The book says that by convention, they often leave the 1 off. The only exception is for the identity permutation. Since there isn't any cycle of more than length 1, you just choose 1 to write it as a single thing. But basically, if it's not listed there, you assume it's mapped to itself. And for the identity, you have to do at least 1. But other than that, you usually leave them off. One, 2, 2, 4, 4, 8, 8, 5, 5, 7, 7, 3, 3, 6, and 6, 1. So that's one giant cycle. I have the same question as you, Jed. I think that the distinction, my guess that the distinction just isn't important. Like, you could take this same disjoint cycle notation and extend it to like a permutation of 100 things, but everything 9 and after is just held constant. Or, you know, it just is mapped to itself. And I think you would get the same exact notation. So if you put cheese in, you get cheese out, I guess so. So I think you can think about with this disjoint cycle notation, you can consider the same function for, I guess, not any number of indices, but a way more flexible number of indices, I think. Maybe there's some convenience in there where things don't have to be the same size, like they do with matrices. Now, part B of this says to decompose this into products of 2 cycles. And I think the book gives an algorithm for how we can do that. Oh yeah, and 2 cycles don't have to be disjoint. Right. These are disjoint. The 2 cycles, they certainly will not be disjoint though. And disjoint means that you're not repeating any of these digits. But the way the book says you can do 2 cycles, if I remember right, is there's many different answers, many different ways to do this. An algorithmic way that always works is to start with the first number in each cycle. You could choose any other number you want to start with, but the first one is the easiest. So 1, pair it with 2, times 1 with 3, times 1 with 4, times 1 with 5. Now we've exhausted that first cycle, so we move on to this and do the same. 6 and 7, and 6 and 8. Does that make sense? If we give it a 1, we get a 2. We give it, wait. If we give it a 2, it gets mapped to 1. This one, no, I may need to flip the order of this. I don't think that's quite right how I wrote it. Curl D adds plus way. Oh wow. No way. Oh. They did the last index. So if you give this thing... Wait, isn't that just the identity? No, that's not the identity. If you give this thing a 4, it gets mapped... I think you read these from left to right. I may need to look back how you read these, but... if you give this thing a 4, I think you go right to left, and I got mixed up. No, wait. You do have to flip the order. Okay. I was trying to do this, or this is more accurate. Whatever, it's not a function. Fair. 6. So you give this thing... Okay, let's give it a 6. This thing does nothing. This does nothing. This makes the 6 into a 1. This makes the 1 into a 3. This thing does nothing with 3s. Okay, I think that's how you read it. If you give it a 5, this thing sends it to 4, this thing sends it to 7. None of these other things have anything to do with 7. Okay. So I need to reverse the order of what I wrote on the board. I forgot you read those from right to left. Actually, who even cares about showing the problem? So we start with 1 and 5. Four, 1, 3. It's gotta be really confusing if someone thinks this is arithmetic. 6, 8, 6, 7. Okay, so if we give this thing a 7, gets sent to 6, which gets sent to 8, nothing else. Yeah, I think this is fine now. 2, 7, 2, 4, 2, 8, 2, 3, and 5, 6 is already a 2 cycle. This thing is 1, 6, 1, 3, 1, 7, 1, 5, 1, 8, 1, 4, 1, 2. Okay. It's an annoying part that comes. We write numbers left to right, write the cycles right to left. Yes. I think the book even says that some textbooks do it left to right, which I think is even worse than... I think people having different conventions is worse than a bad convention there, but... oh well. I think 5? Okay, yeah, 5. Okay, so the order. Now, if I remember right, it's the least common multiple of the length of each of these cycles. Let me confirm that. Probably does, Jed. Let's find out. Oh, really? It's a product of 2 cycles. Cycles of length 2, product of 3, 2 cycles. I think they might define an n cycle up above. Yep, n cycle. Or wait, no, they have 1 cycles up here. They must have an n cycle somewhere. Okay, and my least common multiple thing is right. It has to be disjoint form. If it's in that, if it's not disjoint, then you can't use it. Yeah, they might not say 2 cycle exactly, but hey, Physics 101 over on YouTube, can you ask calculus? Yeah, sure. Feel free to type the problem out there, or if it's easier, you can put it in my Discord. Okay. Left to right corresponds to writing functions x of f. It's undoubtedly a better idea. Yeah. That's fair. What are you saying that x of f, or like, or I guess that's still f of x, but are you saying that that x first notation is better? Because maybe would it be better because you're listing the input first, followed by the output? Is that the idea? For A, the LCM of 3 and 3 is just 3. For 3 and 4, it's 12, right? All right. For 3 and 2, it's 6. For 3 and 6, it's 6. For 4 and 5, it's 20. Wait. They're tricking me. No. This is a trick question. These aren't disjoint. Oh, you sneaky galleon, you. I was like, why is this the same exact problem as the one up here? But it's not, because it's not disjoint. Okay. 1, 2, 4. There's no one. Okay, D is disjoint. What did I say this was? 3 and 6 is 6. Okay, right. 5 repeats here. So if we have cycles that we want to and 2 repeats as well. If we want to unjoin these, hey Dark King, this is me studying abstract algebra. We're currently on permutation groups. I'm studying this out of textbook. It says it's something to do kind of in the downtime while I wait to see if there's a question from chat. I sometimes also study electricity and magnetism too. This is something you would do as an undergraduate math student, probably in like, I mean, depending on the school and the student, like in your 2nd to 4th year. In part E, what does 5 map to? I'm not sure. I'm trying to work out how we separate these. You're preparing for JE? Oh, nice. I've seen some JE questions before. They're not easy. For left to right reader, it's nice for many things. For instance, to read L to right, often to draw arrows. But then there's an annoying thing with function composition. Right. And I've gotten mixed up with that circle notation before. If you write the argument on the left, then it's XFG. That sucks. Yeah, oh god. Why is notation so hard? If I tried JE Advanced QSN, I have not. Okay, Physics 101 is asking to integrate 2 sine of 2x minus cosine x over 6 minus cosine squared x. Oh god. Let me write out the problem on the board so I can look at it. Two sine 2x minus cosine x over Dark King, the one thing that I ask is that it's a problem that you actually need help with. Don't just give me problems for fun or just to quiz me. minus 4 sine x. dx. This is not a nice integral. You're out then, that's your whole life? Hey, hard lucked. Since a double angle. Yeah, so immediately I want to undouble the angle there. I feel like there's maybe an alternate strategy if you embrace having a 2x. But let's first try getting everything to be just of x. So sine 2x is the same thing as 2 sine x cosine x. So we get 4 sine x cosine x minus cosine x. Cosine squared x is the same as 1 minus sine squared x. Oh, we might get something that factors nice out of this. Maybe not. Equals dx. Okay, what happens if we at least attempt to factor the bottom? Factor cosine x out of the top. I think that might be worth doing. I'm hoping we get some kind of cancellation. It might be wishful thinking, though. I don't think we do. That 4 in front is going to mess everything up. Oh! You're not factorable. Well, crap. I don't think the bottom is factorable. Okay, Zone. Wire stress is an idea, yeah. Let me remember how those go. So all the signs would get replaced with this. All the cosines get replaced with that, and we get the dx equals 2 dt over 1 plus t squared. What did you do, Dark King? Oh, you're right, Jed. In the line that I left off on, you could do u equals sine x. And Dark King is saying you might be able to complete the square in the denominator. Okay, yeah, before we go down the virus stress route, let's keep trying with this. Yeah, I think u equals sine x. I completely forgot that the cosine x we can just cancel out with a u sub. And then we'll do what Dark King's suggesting and complete the square. Item completing the square is going to help. Let's, if it looks something nice for you, let's try it. U squared minus 4u. What would we want? We would want a plus 4. Plus 1. Okay. Completing the square would maybe help if we split this up into two separate integrals. Or maybe, ooh, I don't know. Sin x minus 2 equal to t. Oh, so I already have a u here, but we could take a, t equal to u minus 2 or something like that. I think we need to split into two separate problems. I'm going to do that. One over u minus 2 squared plus 1 du. Okay. So over here, I definitely want to do that sub with, oh. Wait, back it up. Let's do the sub right here, like you were saying. Because it's going to affect how we split up into two separate integrals. Because that u, it's going to change the minus 1 right there, which is why I want to do it now. We get u is t plus 2. So 4t plus 8 minus 1. I think it's good. Now let's split up into two separate problems. I'm curious if the Weierstrass sub will be potentially easier, but hey, Abik. I don't think we'd want the square there, unless maybe it happens to work out anyway. I think here I wanted this integrates directly to arctan. This one needs a substitution though. We'll take, I'm running out of letters, S. Just a 2 over S. ds plus 7 arctan t squared plus 1 plus c. 2 over s integrates to 2 ln absolute value of s plus 7 arctan t squared plus 1 plus c. Okay, and then from there, we have to go through we have to unsub a bunch of things, which will be annoying, but we can do it. Weierstrass is more difficult? Oh, okay. Arctan, oh, yeah, thank you, Zone Ranger. It's not t squared plus 1, it's arctan t. I was thinking of the unsub with the s. Okay. So s we know is t squared plus 1. Let's continue the problem up here, I guess. 2 ln t squared plus 1 plus 7 arctan t plus c. T is u minus 2. U is sine x. I'm running out of room. And that's about as simple as you can make it. I think I would call this the final answer. Like, I don't see a neat trick with the ln to make things simpler. Or with the arctan. No worries, physics. Any darking, I called out multiple times, like when I was using your ideas. Do you want like a field medal? Hey, BC Math. Oh, cool, I was about to plug it into Wolfram. Welcome in. And no worries, physics. Thank you for the problem. Two ln. Right. I didn't factor that part out. That's just Wolfram being Wolfram. Arctan is an odd function, so this thing with the signs being flipped is equivalent. Okay. Yep. Nice problem. Does Wolfram do it the same way, actually? Oh, yeah, okay, there's too many identities for just to see the real thing. It's the easiest question in JE. I believe it. The ones that I typically have seen are on the edge of what I can do, if I can do them at all. Okay, so temporary quadruple T. Thank you for the follow. Okay. So in the meantime, I guess we're going to go back to abstract algebra studying. And we had left off on figuring out how to make these cycles in disjoint, because they're currently not disjoint. It was kind of a trick question. Well, I mean, it's not a trick question, but it tricked me. I think we would treat this as composition if we want to find out. We would need to go back to this entire thing manually, and I think go through each of the inputs. Which we can do. I think that's a good thing to do here. Okay. So I'm looking at part E. Part E. And I want to... how am I going to do this? I think I'm going to write a matrix for what the permutation is, and then put it into disjoint cycle form. There's probably a quicker way to do it. Temporary is asking a question. How much integrals did you solve for your lifetime? Good question. I've solved Hmm. I don't even know how, like what number to put on that. I would guess over 1,000, including all the calculus classes I took, and like differential equations has some integrals. A dozen less than tomorrow's answer. I solved a lot of integrals. I've been doing this stream for a year and a half or so. And integrals are probably like one of those popular types of questions. And then I also have a major in applied math, so there are plenty of integrals involved in that. Funny mods for the win. Jed's awesome. Dark King, let a be an integer such that all the real roots of the polynomial 2x to the 5th plus 5x to the 4th plus 10x cubed plus 10x plus 10 by the interval a, comma a plus 1. Then the modulus of a. Yeah, and Jed is always right too. Do you actually need help with this, Dark King, or are you just quizzing me? Like, is this a problem that you need help with, or are you just giving me a problem for fun? It's okay if you are. I just prefer not to work on. If you just ask me a question for fun, I prefer not to work on it. All right, I'll place over to the Twitch chat, but I guess regardless, I'm not even sure how to do this offhand. Like, the modulus of a. Let me take that off the screen. They only say the real roots. Not rational roots. You cheated? Is it something... Does it have real roots, I guess, first off? There's only one? Okay. Yeah, Darking, like, if you're working on this style of question, I'm not gonna be that much help. Like, I can sometimes figure out how to do these questions, but they're definitely not something that I have solved usually ever, but if I have solved them, it's like maybe once ever. I feel like you could get a numerical estimate pretty easy. I mean, Darking, I'll work on any question that, as long as you actually need help with it, and I can actually do it, I'll help. I just can't do this, like, easily at least. I'm trying, but like, I just don't exactly know how you do this. Like if I just randomly plugged in 0, how far off are we? We're at 10. We'd have to try a negative number because there's no subtraction in the polynomial. It's like -1 would be -2 plus 5 is 3. Minus 10 is -7. Minus 10 again is -17. Plus 10 is -7. Oh, wasn't that our... Oh, wait, okay. If you plug in 0 to this thing, you get a positive number. If you plug in -1, you get a negative number. I think A is just -1. By intermediate value theorem. I don't know if there's a proper way to do this. Well, they're not asking for the actual root. They're asking to estimate the root, basically. Like find the integer just above and just below it. 1 plus 1 equals what? 2 syntax error? 11? I actually thought that as a kid before I was ever in school. So yeah, they're not asking for the exact root as far as I know. They're just asking for the nearest integer above and below, basically. And so I tried plugging in -1, and I got a negative value. I tried plugging in 0, oops, and I got a positive value. So you know it has to happen between -1 and 0. Yeah, basically. So if one is as soon as the sign changes, you know it has to have crossed 0 somewhere in that interval. It's called the intermediate value theorem, I want to say. I sometimes get them mixed up. Yeah, and it's a polynomial, so it is continuous, but where would it be? Paul, where did you put this? I should just Google it. That's gonna find it faster. It's Paul's. Come on, Paul. There we go. I mean, it's not specific to a 0. I wonder if, I feel like there is one that's maybe specific to a 0, but who cares? When you plug 0, you get a positive. If you plug 0 into that polynomial, you get 10. If you plug -1, you get -7. Bolzano? I haven't heard of Bolzano's theorem. I know Bolzano-Weierstrass. Oh. Intermediate 0 theorem. Actually, I haven't heard that, so maybe I just assumed to have an exact name. Yeah, but it is the intermediate value theorem, just a particular case, as they say. -1 is 3. Oh, I might have done some mental math wrong. Actually, no, I'm pretty sure it's -7. Yeah. If x equals... Oh, I'm not showing my Firefox. Oh, I thought I was showing it this entire time. My bad. I've had the graph of this thing up the entire time. -1, -7. Either way, though, as long as you know it's a negative number, that's the important part. So the actual value doesn't actually matter. As long as you do enough mental math notes, it's negative. That's the only important part. Let's prove it only has one root if its derivative is always positive. A cubic with one real, I mean, no, not a cubic. It's like a cubic, but whatever to the 5th power is called. Oh, true, yeah. This would have a positive derivative always. Quintic, right. Thank you. Physics 101, please teach some tricks for calculus. That's a little bit too general for me to just like say general tricks for calculus. I can give you this website though, which I really like for everything calculus. Just look in the sidebar and whatever you're having issues with, they probably have a page on it. But I really enjoy this website for giving very practical explanations of what you actually need to do when you see a problem. It doesn't go into the theory very much at all, but I don't, for most students, they just aren't tested on that anyway very hard. So it's very much geared towards like actually solving questions you'll see on homework and tests. So it's definitely called a quintic. Pentic, that sounds cool, but I never heard anyone call it that at least. I assume it wouldn't be wrong to call it that though, as long as the roots are proper. Wait, Darking, it's between -1 and 0, not between -2 and -1. A is -1. And the modulus of that, I guess, is 1. How about an MIT integration bee problem? One has been bugging me a bit. I've looked at them before. If it's like an easy one, I think I can do it. It's second to last doesn't mean it's hard. I mean, I'll look at it, I guess. Dark King, either you're wrong or you gave me the wrong polynomial. The real root is at -0.7. Yeah, links are allowed. But either way, I think you get the idea, Dark King. So I guess you, if there is some type of error that I've made, I guess go with what you're saying. But for this polynomial, the answer is definitely, or it's definitely between -1 and 0. I bet. I mean, Wolfram. I don't know. Probably Wolfram can't do all these. Oh my gosh. Zach and Penn Center, I feel like I've seen Zach kind of recently engaging with MIT integration bee problems. But I think Zach and Penn Center are probably going to be like the best bets for these, but I'll still try with this. So you're saying it's 19. Well, then you should do this integration bee because I don't know what the prize is, but oh, that number 20 looks crazy, but that wasn't the question. We're looking at a 19 here. Arctan of 2 to the power of cosine x from 0 to 2 pi. Is there a discontinuity there? No. Favorite area of math? So I majored in applied math, and the thing that I enjoyed the most was using differential equations and systems of them to model real world scenarios. And so we use those to talk about the predator prey equations, and as a research assistant for a professor, we use them to model how a social media trend that goes viral will grow super quick and then die off again, and trying to predict which trends have if you can predict whether a trend will blow up early on by looking at the shape of the curve, basically. There you have circle. There you go, Dark King. I'm trying to figure out some way we can involve exponentials or a logarithm, but not easily that I see. Would a triangle help here? What would this mean? Arctan, 2 to the power of cosine x would be the opposite. $19, Dark King. Guys, I'm at least looking at it and see if I can get an idea. I doubt I'll be able to actually do it. Hey, SPQ. Right, Jed. I mean, that might come in handy somehow, but we can't. It's not as simple as just taking the two endpoints. We need to know what the antiderivative is. Unless there's some symmetry that we can take advantage of. No. Arctan is an odd function, but that doesn't help us here. Symmetry from 0 to pi and pi to 2 pi? If I looked at just arctan, I'm interested to see the actual graph of this too, but I don't see a symmetry between 0 and pi here. Or a boring roller coaster. Oh, okay. Oh. Actually, I don't know what I expected. But that kind of makes sense. Oh, and this thing is symmetric. Okay. Right. I can see that now. So we could cut the interval in half and multiply by 2 to get the same answer. That doesn't seem amazingly helpful yet, though. But we should expect a positive answer here. Such functions are Feynman's trick is needed. arctan, or yeah, tan inverse, it is increasing. It levels off, but it's always increasing. Hey, Thunder. Does the... I don't know what tricks the... Will the integration be... like, considers fair game? No outside materials are allowed, don't cheat. Well, that's just too bad now, isn't it, MIT? Sandwich theorem, Dark King says? That could be a thing. I don't know what's close enough to sandwich it with, though. Like, what would arctan of cosine of x... like, is arctan of cosine of x comparable with this? I mean, I know what it is, Dark King. I don't know how, like, what to sandwich it between for 19. I assume they take care of that for you. They just want your estimate, and they get the ratio. Hey, Nabed, do you solve permutation and combination? If it's a basic one, I can. I'm not very strong on those types of questions, though. Feel free to type it out, and I can tell you. Or I have a Discord you can put questions as well. One E minus infinity. Do they teach you more integrals in college? You usually don't. Well, yeah, you learn about a lot of different types of... None of them are nearly as hard as the ones that we're looking at here. But in college, for Calc 2 and Calc 3, like, you have to do some... In Calc 2, you do integrals that are hard to find the algebraic manipulations for. In Calc 3, you do integrals that are hard to find the conceptual understanding for. Yeah, sure, Thunder. Feel free to send it. I'm not super married to trying to figure this problem out here, because I make no promises with... Oh yeah, physics. This is MIT Integration B, which is... They have some insanely difficult integrals. Oh, and Navia is asking their question. There are 3 sections in a question paper. Each section contains 5 questions. Candidate has to answer a total of 5 questions, choosing at least 1 question from each section. Okay. And I assume there's going to be more after that, because YouTube is pretty short character limit. Complex arctan. Number of ways. Three sections in a question paper. I'll copy this over to Twitch chat too. I just need to figure out what the question is asking. I think I'll be able to do it though. So there's 15 questions total. We're choosing 1 from each section. Are we choosing 1 question from each section, or are we choosing more? One from each section? Oh, so I think at least 1 from each section. Ooh. So yeah, if there's at least one, we have to consider some different cases, I guess. Syntax, I'm sorry. Since there's a question from Navi and then a question from Thunder, I'm going to give this MIT integration thing a bit of a rest. Because I don't have high hopes of being able to do it. But if there's time, I can try and come back to it and think about it more. But in general, Zach or Python are probably better bets. In Physics 101, if you remember how to do this, please feel free to type it out there. Or if you even have a hint or something. Oh. Well, maybe this... No. How does this work? So just to like... spell out one or two of the cases. Well, no, I thought I had an idea for where this is going, but like, if we have to do at least one, how many ways are there to choose at least one question from each section? It means we could do all 15 questions. We could do one from each section. We could do two from one from the others. We could do like 2, 3, 4, or something like that. And I'm getting a little bit lost in how we actually count through these different cases. Oh, the total of 5 questions are answered? Did I miss that? Oh, I did miss that. Okay. Okay, that makes it a lot easier, I think. There's not near as many cases to consider. Okay, so if we're only answering 5 total questions, fix one from section 2, one from section 3, and count for section 1. Go by... Probably do this. If we answer one question from sections 2 and 3, then there are 5 choose 3 ways to answer questions from section 1, I think is what we'd want to do. One question each. And there's 5 ways to answer one question from section 2 and 5 ways to answer from question 3. And then I think we need to multiply this by 3 because we could have done this for any other like section as well. BCE math, is there a log of all the problems asked somewhere on stream? Not really. I would like to have at least make some kind of queue of questions for during stream. I haven't really gotten around to it though. There isn't one central place you can go and just look at all the questions. I do have a Discord server, like Jed said, where you can see some of the questions. But I get them from Twitch chat, from YouTube chat, from Discord, and some people just like DM me as well. So it's kind of from all over. The next best bet is that on the YouTube channel, I try to be as descriptive I can of the questions that I've answered in the like the metadata for the video. So if you tried searching a question, you might be able to find it on the YouTube thing, but that's what I want to do, BCE math. It's not as simple as it might seem though. And I want to do some more things with it than just that too, but there's a lot of complications with doing that. And sorry, I am still thinking about this combinations question. I stream gaming on Twitch as well, and I have a gaming YouTube channel. It's not terribly active though. Hey, Toji. So that's 5 times 5 times 5, choose 3, I think, times 3. Or do we add these? Or like, do we add these 3? I feel like we add these. I can't explain it though. Multiply by 3 still though. And then I think we have to do another case where if you do like 2 and 2, and then that would cover everything. Brilliant math. Oh, well, welcome in, Toji. I dual stream to Twitch and YouTube, so the Twitch chat is what you see like right up there. Probably over on Twitch, there's a whole little like math community if you are interested in switching over. But on YouTube, I'm not as aware of many math streamers. One question from section 3 and 2 each from 1 and 2. Here you would have 5 choose 2 plus 5 choose, oh my god. 5 choose 2 plus 5 all times 3. And so I think my answer would be this plus that. Whatever that is. Let's give it to Wolfram Alpha, I guess. Secret alliance of taking math streamers, you know, maybe. Megumi? I don't see a Megumi in chat. Oh, wait, I don't know what you're talking about, Dark King. Yeah, I have the multiplication by 3 here, Navia. Oh, okay. How does Wolfram like choose? 5 plus 5 plus 5 C3, I think Wolfram Alpha likes 5. 5C2 plus 5C2 plus 5 times 3. Fenlock's got 2250. Oh, come on, Wolfram. That's what you think I meant? In Thunder, you're on deck for after this one. Really? I think this actually works, stupidly enough. Oh, it almost worked. $135? That's a little bit less than what Fenbox got. I was debating between multiplying and adding. Multiplication feels right. The answer is 2250? Okay. I think multiplication. Maybe I was overthinking the multiplication part. And sorry, Jed, you said, does the idea of doing 5 choose 1 3 times 12 choose 2? I don't know. I'm not good enough at these questions to know. Zone Ranger saying 15 choose 5 minus 3 times 10 choose 5 plus 3. Huh. I still don't get 2250? No, I get 900,000. The hell? Oh. There we go. 2250. Yeah, I'm not able to unpack like how you would. I do see Zone Ranger's answer is like getting all the combinations and eliminating the ones you don't want. I have no idea how to do that like for myself though, I guess. Let me look at Thunder's problem. All right, see you, Dark King. Question 8. I'm confused about what the limits are in terms of t and u. Or in terms of t, and can you use the formula pi integral x squared dy dt dt? Wait, question 8. What the limits are in terms of t. Question 8. What the limits are in terms of t. Coordinate geometry? No. I've done almost, I've done basically no coordinate geometry. Oh, wow. A solid revolution with a parametric equation. I'm sure this is possible. I don't know. I haven't done this out. I don't think I've done this though. Yeah, you could definitely convert it into like a non-parametric thing, like Fembox says. Actually, yeah, that's not too bad at all. I wonder if you can keep it as parametric though. I assume there's a way to do that. What would the radius of the circle be if you're doing washers? I think you could do like root. Maybe not, you don't even need the root because it's r squared. Wouldn't you be able to do like dx dt squared plus dy dt squared, that integral? Oh yeah, thank you, Fembox. Not do it with Cartesian. I'm betting if we do it with washers, the formula is going to be, well, is it? You're saying the formula is x squared dy dt dt. Huh. Okay. Ah, go away. No. Wait. Where's the parametric? What? Did I get lied to? Okay, so that's the same formula. I don't know. I need to learn where these actually come from. I feel like that'd help me remember them better. But I mean, I know where they come from for normal washers and shells. But anyway, revolving around the y-axis, we said, and so we can use the formula that you said, Thunder, of the y-axis through 2 pi radians. Oh, that's such a weird way of saying that. Just say it's a complete revolution. Oh my god, I hate that phrasing, but okay. Yeah, I think with that formula, I can figure out how to do this problem. Oh, did you send the same? Okay, yeah, that's the same formula as I was looking at. Yeah, so we're gonna use that formula, Thunder, yeah. So x is 1 over 2t. It looked like they expressed the same thing in a slightly different way, but it was ultimately the same thing. Uh, 16 bits. Thank you, Hardlocked. Math is fun. Navia, if I can do it, I'll try. I can't promise I can do every question, though. If you send another. T is greater than a half, which doesn't mean all that much. But the thing you're asking about first, Thunder, is how we get the bounds. The curve goes through the x-axis. Really? Oh. Okay, sure. Really? Oh, okay. I had it oriented wrong in my head. Okay, so the region that we're given, basically, one end of it is where it meets the x-axis here. The other end is where y equals a. And we need to figure out what t's go with this point right here on the curve and this point right here on the curve. The thing we know about this point is that y equals 0. So let's plug that in up here and solve for t. Raise each side to the power of e. E to the 0 is 1. T equals a half. That's actually our starting point too, so that makes sense. Now let's figure out where this point is here, and the thing we know about the point is that y equals a there. So let's take the same formula for y and plug in a instead. Raise each side to the power of e. And you get 1/2 e to the a. hashtag sponsored. So 1/2 e to the a. We don't even have to care about x here particularly, as long as we're not dividing by 0. And we're not, so. Equals that. So if we go to the formula, what's up? You think you got it? Oh, is that all you needed? Or do you want to see the actual integral? You did your oh, okay. Okay, sounds good. Just so I can see how to do it, I'm going to do the integral anyway, just because I haven't really done these problems much at all, if I have done them, so. Oh, yeah, well, okay, yeah, I'll look at your other question first then. The answer is ln7? Okay. Oh, I see that you put your question in there, Navia. Tangent cubed of 2x times secant of 2x, integrate that. Ooh. Oh man, they gave you powers specifically that mess with doing a U sub. It's either chat or Discord, Navia. I don't have a third option. How would you want to... Tangent cubed of 2x times secant of 2x. I'm pretty sure Paul is like a helpful, thing here. Like if your power of one thing is odd, the other is even, you do this. If one is odd, one is even, you do that. Really? I swear that Paul had something like this. Oh, true. Yes. I forgot about that. I would do that and take u equal to secant 2x. And you should get something that's not bad to integrate at all. If you want, I can actually show it out on the board, but I see that Thunder sent another question. But I think he found the idea before I did. Six C. You haven't done it in a while. It'd be nice if you went through all of question 6. Okay. Yeah, my algebraic equations is a little bit rusty, so I'm gonna have to look this up. But right. These are the equations for a circle. I forget how you actually go between them. Do you just consider x squared plus y squared? And something good happens? Usually it is written with x minus... Oh, yeah, that's interesting. I mean, a can be negative, Navia, but yeah, it usually is written with x minus a and y minus b. This is valid too, though. So like often with parametric equations, you could solve one of these for t and plug it into the other equation and you'll get something with x and y. With circles, you can't, like that's a little bit harder. And I'm trying to remember how you would undo this. Yeah, we're definitely gonna need sine squared because cosine squared is 1. I don't know if it'll disappear entirely once we do all the squaring. I mean, that's my only idea anyway. Like, let's just try this. I'm not the most optimistic about it though. Don't solve for t. Oh, that's really clever, Bluebird. I love that. Yeah. Okay. I'm just gonna erase this. So we have x is 9 cosine t minus 2. And y is 9 sine t minus 1? Was it? Plus 1. And see, what Lubert is saying is in each of these, isolate the sine t and the cosine t, and then we'll do a little trick here. So we get cosine t is equal to x over 9 plus 2 over 9. And sine t is equal to y over 9 minus 1 over 9. And the trick here is that we remember sine squared t plus cosine squared t is 1. But sine t is y over 9 minus 1 over 9, and cosine t is x over 9 plus 2 over 9. That's really clever. So we can do these subs here. So we get y over 9 minus 1 over 9 squared plus x over 9 plus 2. It's not a 9, it's a y. Squared equals 1. And now we have some algebra to do. Actually, not even that much. We multiply each side through by 9 squared. Right? Or do we do it by 3? Or by 9? Wait. We want the 9 inside of there, so we would want... No, wait. Square root of 3 squared. Okay, I think we're going to play each side by 3. No, wait, I did that backwards. By 9 squared. Yeah, okay, let's not overthink it. Multiply each side through by 9 squared. Because I'm not good with my exponent rules, I guess. And the reason I'm saying multiply through by 9 squared is because we get 9 squared times y over 9 minus 1 over 9 squared plus 9 squared times x over 9 plus 2 over 9 squared equals 1, 81, because 9 squared. And now, because these are both squared, we can rewrite them under one set of parentheses sharing that squared. And I normally want to show this much detail, but since it was giving me trouble, I figure I should show out each step of applying the exponent rules here. And now this 9 can get distributed inside here, and we get y minus 1 squared plus, I'm writing in backwards order, but x plus 2 squared equals 81, or usually you put the x first, so I'll just do another line for that. There we go. So this is a circle centered at -2, +1 of radius 9. God, okay. That's for part A, though. Sketch the curve C. Oh, hey. On the given domain of T, -π/6 to π/2. So notably, this is not a complete revolution of the circle. So your options are to either take this Cartesian form and draw the entire circle and then erase a part of it. But I kind of like maybe doing a combination of both of those, like maybe I'll draw it over here. -2, +1. 1, 2. Oh god, it's radius 9 though. What an annoying radius. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I only needed 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. I counted something wrong, but it's fine. 1, 2, 3, 4, 5, 6. That's only 7. I don't know what's good or bad, but we'll find out. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we're centered at -2, +1. And then I want to plug in -π/6 to figure out where we're starting. And I'm going to plug it into, so like I'm getting the center from the Cartesian equation, but I want to get my 2 example points from the start and end points of t's, which are from these equations. So if t equals -π/6, we get cosine of -π/6 is +√3/2. Oh, times 9 minus 2. Oh, what is that? That's annoying to graph, isn't it? 9√3/2 minus 2. Whatever that is. Sine of -π/6 is -1/2. So -9/2 plus 1. What? They don't want you to work that out, just to sketch, so they're saying guess it. Well, it's going to be, I'm not going to like get the exact values for these, but it's not going to be the entire circle, and I don't know. Oh wait, am I overthinking this? I'm overthinking this. It's just a -π/6 angle from the center. Okay. So we're gonna go. I think we take this as the center of the circle, and we just start with a -π/6 angle. So like 30 degrees down from the horizontal. I think I'm way overthinking it. Yeah. Okay. I don't know what it's gonna. Let's count out 1, 2, 3, 4, 5, 6, 7, 8, 9. Just so I know like a bit of the scale. What is it? I know that because of the bounds of t. Sine and cosine both have a period of 2 pi, and this does not cover 2 pi worth of angles. It's a little bit over 90 degrees even. Like, the unit circle, you know, this one is centered at 0, 0. We're only plugging in angles like from there up to there. And so I think we're going to have this same arc, but transferred to this center and blown up to a radius of 9 rather than a radius of 1. That's what I'm going for here. So I just started by going out directly to the right by 9 to make it a little bit easier to figure out the scaling for by minus pi over 6 angles. I'm going to guesstimate it's around there for the start of the circle. I shouldn't draw that. Oh, shoot. I shouldn't have drawn that line. That's not an actual part of the curve. It's just a radius. Ugh, okay. So I'm going to say this is our starting point, and we're working our way up and around. What is that? Oh, it's a 7. Okay. And pi over 2 is directly up, so let's count up by 9, which I already did to get 10. And so I think the actual curve is this portion of the circle, starting from here, going to there. So I'll put an arrow like there, because parametric curves have a direction. They may not emphasize that part of it, though. I'm not sure. Oh, shoot. I made that drawing with the unit circle, and it was covered up. But the way I worked out that it's this part of the curve is I took the unit circle and thought about the starting from minus pi over 6 and going up to pi over 2. And so I took this exact like arc from here to here, and I just transferred it to the situation we have, which is an offset center and a much bigger radius. But it's the same angles. Okay, and you're actually asking about part C. And this has a formula, thankfully. Actually, there's 2 ways that we can do this. So if we want the length of this curve, oh, you think you got it? Okay. All I'm going to say is that there's a calculus way to solve C, and there's a geometric way to solve C, and the geometric way is way easier. Okay. But if that's all you need to know, I won't... Yeah, exactly that. I was trying to read back, so I thought you were going to do it the calculus way, which that one I happen to remember offhand, but it's way more complex than you need for this problem. All right, but neat question. Thank you. Hey, Phoenix. Yeah, sure. The graphical interpretation of sine. Oh, yeah, no, this one on the screen is just something I was looking at for fun. Oh, yeah, I can help you out with that. Let me quickly answer Navia's question. If you want the graphical interpretation, oops. Here it is. Basically, the closer you go to 0 of this graph, the higher the frequency becomes, the more it goes up and down, like, or the faster it goes up and down. So it's pretty fun in Desmos. You can just keep zooming in on this, and it never. It's just always this big green bar because sine is getting infinitely. It's probably a good word that I can't think of. But the smaller the number you're plugging in closer to 0, the bigger the input of sine is, and the faster your fluctuations are, just because of the way that sine works. So eventually Desmos kind of breaks, and you get just a green screen. Yeah, the frequency tends to infinity. Just because you're plugging in bigger and bigger numbers, and the actual value of sine, when you're dealing with big numbers, if that makes it fluctuate more. Actually, that's not quite right. It's because 1 over x around 0, it's increasing super rapidly. It's like a small change in x gives a big change in 1 over x when it's close to 0. Whereas over here, a big change in x gives you hardly any of a change at all, which is why on the right side, it levels out. But close to 0, it's just increasing faster and faster and faster. So even though you're doing a very small change in x, you're getting a very, big change in y. Or yeah. Also, that's kind of cool. You can see the graphs of them are nearly the same for big values of x. And I think that's from sine of x approximates x for small values. Okay, let me look at Phoenix's question. You need to evaluate 1 minus I root 3 to the power of 5. You can definitely do that. Okay, so in theory, you could multiply this by itself 5 times, but that's a huge pain, and it's way more work than necessary. We have this is complex numbers, which means we can put this into polar form and have a much easier problem. So I'm actually putting 1 minus I root 3 into polar form. Which is r e to the I theta. So we need to work out what r and theta are. R is just the square root of the real component squared plus the imaginary component squared, which is root 1 plus 3, which is root 4, which is just 2. So r is 2. Theta is arctan of the imaginary component divided by the real component. Now that's where we have to do a little bit of geometric checking, I guess. If we graph 1 minus I root 3, the real component is positive 1. The imaginary component is negative root 3, which is just slightly over 1. So we have a point down here in the 4th quadrant. In arctan I think is going to give us the proper value in this case. If we had an angle that was like in the second or third quadrants, we have to do some extra work here, but I think we'll be okay. So if you know your unit circle, arctan of minus root 3 is going to be minus pi over 6, I believe. Because you want, it's going to be, no, it's y over x. It's minus pi over 6, or pi over 3. Yeah. Okay, yeah, it sounds like you agree. Minus pi over 3. So in polar form, then we get 2e to the I times minus pi over 3. We could convert that into a positive angle. Let's do that. Just so I don't have to deal with the minus sign in the exponent. Pi over 3 minus pi over 3 plus 2 pi is equal to 5 pi over 3. So I'll just use that instead. I don't know if there's... I'm taking actual complex variables class, so there's some conventions that I'm not aware of, but I have done problems like these a lot. I don't know if it's people usually convert to the positive part or not. Either way, it's the same thing though. We're still raising this thing to the power of 5, but now it's much easier because we can just use exponent rules on this thing. So the 2 can be raised to the power of 5. Oops. 2 to the 5th times e to the 5 pi over 3 to the 5th. 2 to the 5th is 32. And we have a power to a power like this. The powers multiply. So I'm going to say it's e to the I 25 pi over 3. And I think that's just your answer. You could probably, that's outside of the 0 to 2 pi interval, so you could probably subtract off some 2 pi's until you're back there. But I think this is technically right also. That's another thing where I don't know if you're supposed to convert that back to be, if you don't convert this to be in a more normal angle. We can do it though, just to show it. It might be that like as soon as you're here, you're done. But the 25 pi over 3, it is a little bit of a weird angle. So it's gonna be subtracting off 6 pi over 3, 19 pi over 3, minus 2 pi. Well, I shouldn't do it like that. (13 pi over 3). 13. I'm sure there's a better way to do it than this, but that's how I'm doing it. 7 pi over 3. Nearly there. That's just pi over 3. Ah, look at that. There you go. So I'd say the simplest version of the answer is 32 times e to the I pi over 3. And we can put that back into rectangular form as well if we wanted. It would be 32 times cosine pi over 3 plus I sine pi over 3. Cosine of pi over 3 is 1/2. So 32 times 1/2 is 16. Sine of pi over 3 is root 3 over 2. So the 32 gets divided by 2 again to be 16 root 3, and there's an I there. And let me check that in Wolfram just to make sure I didn't royally screw something up, but I think we got the answer here. Oh, yeah, 16 plus 16 root 3i. Perfect. So yeah, well, let me know if there's a part of that I can explain better, because I kind of meandered around there. But yeah, if you have a complex number to a power, as far as I know, you always want to put it into polar form like that. Yeah, well, I'm gonna have any questions on that or another question to ask. In the meantime, I'm interested in trying to see if I can say anything remotely intelligent about this problem. I don't think I can, though. Demols. Oh, the sign got messed up? Yeah, I mean, I think I secretly did Demols without actually saying it. It's easier for me to remember the procedure like here. The issue must have been, yeah, I can see how their angle for sine would get flipped. Why did the mob seem to steer us wrong there? Yeah, I'm doing it in my head. I'm making the same error as you right now, and I'm having a hard time figuring out why. Sine. So we get cosine of minus 5 pi over 3 and sine of minus 5 pi over 3, right? Oh, I see. Yeah, it's because cosine minus plus I sine minus 5 pi over 3. It's because of minus 5 pi over 3 angle on the unit circle. You go the other way all the way around, and you can find it's the same angle as positive pi over 3. If you did it for like positive 5 pi over 3 is like down here, but it's a negative 5 pi over 3. So I think that's why. It's maybe more able to convert the minus 5 over 3 to pi over 3. Add 2 pi to it. Because minus 5 pi over 3 plus 2 pi is actually pi over 3, positive. Like what I was evaluating in my head was cosine 5 pi over 3 plus I sine 5 pi over 3. But that's not what the problem was. There was a negative sign in front of each of these. For the cosine, it doesn't matter. But for the sine, it does. Like, the negative sign there makes the difference. It is the issue. Awesome. Glad I was able to help. Oh, Suna, hey, how's it going? Go to probability? Oh god, I'm not very good. I'm doing well too. Thanks for asking. How have your studies been? Yeah, I mean, not be like others. I'll give it a try, but my probability isn't very strong either. The only thing I think I have to do with this one is try to do inertia by parts or something, but I don't know. They cat up in math in the end. Okay, fair enough. Okay, we got a question from Navia. A die is thrown 2 times. Okay, pacing over to the Twitch chat. The sum of the scores appearing on the die is observed to be a multiple of 4. Conditional probability that the score 4. Ooh. In theory, I should be able to do this, I think. So if we're given the score 4 has appeared at least once, if we're given that one of our rolls was 4 and we're only throwing the dice 2 times, or the die 2 times, the other one must also be 4. There's no other way to throw that die. But there are 2 different cases where that happens, one where the first throw is 4, one where the second throw is 4. And so would this be 1/6 plus 1/6? That's my guess. Because it's independent. Or maybe it should be 1/6 times 1/6 plus 1/6 times 1/6. Oh wait, or maybe not. The conditional, maybe I'm thinking about this wrong. Maybe it's asking, given you rolled an 8, what's the probability you rolled a 4 on at least one of the rolls? I think maybe that's what it's actually asking. You want to do this, I think? Yeah, I learned to do problems like this. That was a long time ago, though. You're getting 1/9? Yeah, let me try and write out what it would be in terms of that formula. Because I think when I was first thinking about the problem, I was doing it backwards. But I think we're given that we rolled the 8, and we want the probability of having rolled a 4 at least once. Which really kind of forces the other one to be a 4 as well. Wait, what order is this notation? P, B given A? Yeah, okay. So the probability that we have an 8 for the total given at least 1 4 is equal to the probability of 8 total. That's not how you spell total. I was already starting to write and. Over the probability of at least 1 4. That's all. I think that's how we should interpret this. I hope. Because I don't see. There's no other multiple of 4 we could possibly make if one of our rolls was already a 4. So, yeah. So the probability of getting an 8 total and at least 1 4 is 1 6 times 1 6, right? Over 1 6 plus 1 6? What would this work out to be? One over 18? No, 12. I'm not that confident in this though. I thought the way the question is phrased, we only are worrying about 8. Or like, if we're, can just probably, oh, maybe I'm doing this backwards still. We're given it's a multiple of 4, but or the score 4 appeared at least once. If the score 4 appeared at least once, I was thinking our only option could be 8. So we don't have to worry about 4 or 12. Or am I still doing this backwards? We're given it's a multiple of 4, and what the probability of having rolled a 4. That might be it. I might have this conditional backwards. I love math in high school. I'm now in medicine school. The last time I saw an equation was more than 2 years ago. You clearly forgot everything. Emo giraffe. Sorry. A, welcome, and B, if you don't use it, you'll lose it. When I first started out this math stream, it was bad. I had graduated like 5 years before, and I had hardly used my math since. And I was struggling with even more things than I am already struggling with. So, I mean, it takes work, but you can always get it back. We own the probability of rolling at least 1 4, given we've rolled total equals like a multiple of 4, I guess. So 4 times some number. That's a terrible way of phrasing it, though. I shouldn't say it like that. So this would be, I'm just gonna write and. I don't feel like writing all that stuff out again. Over the probability of multiple of 4. So for these things both happening, the only time that happens is a 4 and a 4. And so I think that's where we can do 1/6 times 1/6. And I don't think we need to do it times 2. I hope not. But getting to the bottom is going to be kind of tricky, isn't it? Because you have to worry about all the different ways you can roll a 4, all different ways to roll an 8, and all different ways to roll a 12. Thank you, Phoenix, for the kind words. Maybe it's not so bad. Like, the probability of rolling a 12 is just a 6 plus a 6, because 6 and 6. Well, 4 and 8, you have a lot more possibilities there. That's kind of mean. How do we start to roll a 4? You can do 3 and 1, 1 and 3, 2 and 2. Would I have to count 2 and 2 twice? It's confusing. I don't think I would. There's 3. I'm going to say maybe there's 3 ways to roll a 4. I don't know how many total possible rolls there are. How do you get the bottom? Like that. Oh. What the heck? I got signed on my YouTube chat? Let me look into that. Sign into chat. What the hell? What are you doing to me, YouTube? Give me 1 second. My YouTube chat is all sorts of weird right now. There we go. Okay, it's fixed. I wonder if it's still gonna be. Hey, I'm actually DDM on YouTube now. It kept defaulting me to my gaming channel. It was really annoying. How do you calculate the bottom? There's way too many things to worry about there. Like, so I'm wondering if there's a different way to do this problem. I can't really figure it out though. I don't know. Just do a freaking integral? Hey, Scrimp. It'd be nice, but let me see. I mean, someone else posted something in my Discord. I doubt that I can do it though. It said question 37. This one in the middle. This is definitely a competition problem. Hmm. I was wondering if it was worth factoring a 2 out of the denominator. I don't think it really is worth it though. Yeah, I have no clue. This problem was ridiculous. Um, hey Phobos, how's it going? Oh, that's an interesting idea, Scrimp. Going, yeah, 37. Scrimp has an interesting idea, or over in the YouTube chat, Scrimple said we can multiply the top and bottom by 2 to the minus 2x and maybe get a power series out of this. Let's see what that looks like. But I hope your week's been off to a good start with all that you've been doing. So on top we would just get 1. Oops. Like that. Two to the 1 minus 2x. That could be something. I don't have a power series. It does almost like a power series, but would it be that simple if there's another function in there? Hey, I like a PC. X is always less than 1. I mean, maybe I'm just crazy, but like, if you have 2 to the 1 minus 2x, can you literally just, maybe you can just plug the 2 to the 1 minus x into that power series. Using this thing. But instead of x, we have 2 to the 1 minus x, which is the part that was tripping me up. But I guess we can, I think we can do that still. I guess it's a negative sign in front. This is 1 minus x. Would you do the partial sum for a geometric series? How would that work, though? I think it's what you should do. The denominator of how the indices work, though. Hmm. It's at least right. What the claim is in terms of Taylor series. To start from, I need to look at what the starting index is. I think it's 0. It's 0. And I think that's okay to do, just like, I feel slightly wrong with that part, but oops. That's at least slightly more right, but I still don't... If it is okay to just take that 2 to the 1 minus 2x and slam it in there, we need to figure out a way to... I don't want to, like... How do we make it sum 1 over 2023 to 2022 over 2023? That's what I'm stuck on. It seems like a good idea. Okay, yeah, so once you plug in values for x, you have 2022 different series. That seems, or maybe even 2023 different series. And hopefully we get cancellations, is what you're saying. Is this fundamentally different from if we had done this to the original function, though? Just plugging in each x value and looking for cancellations? Okay, let's just try it anyway for a few of these x values with this series and see if something obvious happens. So if x is 1 over 2023, 1 minus 2 over 2023 is minus 2021 over 2023 to the n plus zero to infinity minus 2, and I guess that's going to be minus 2020. Wait. No. If x is 2 over 2023, we subtract 4 off it, so 2019. I'm not seeing anything yet, anyway. Yeah, I don't see an obvious cancellation here because the exponent's getting multiplied in. If it was adding something, then great. But all the signs are in sync with each other. Yeah, I don't know how to do this one. I think I might just move on from this problem because I just don't know how to do it. I'm gonna go back to some abstract algebra, I think. Just for a little bit, and then I'll probably call it. So, earlier in the stream, we were looking at this abstract algebra problem with permutation cycles. And for part E, they don't give you disjoint cycles, and they need to be disjoint to easily get the order. And I think the only way you can really get these to be disjoint is to look through each or, you know, look through it one number at a time. And rewrite the cycles from scratch. So, how do we do that though? I need to look at how the book did it. Yeah. That's probably the safe way to do it. I feel like the book took a somewhat of a shortcut though. That oh, Obi. Thank you very much for the raid. How was the stream? Welcome in, everyone. For anyone here who's not already aware, I hope everyone is, but I've always been doing a differential equations class on Mondays and Wednesdays. Stream is oh no, okay. See you in a minute then, hopefully. But yeah, if you're interested in differential equations and learning about them, you should check out his channel. All right, so this is their example of a non-disjoint cycle. Okay, so I was worried if this would have to, so I remembered how to do like this part of the procedure that they give, but I couldn't remember if you start going from left to right or if this would have to be from right to left. It looks like we're going left to right though when we write this out, so. And if they're disjoint, maybe that's not so important. Do disjoint cycles commute? I feel like they should. Yeah, okay, they do. And I was worried about nothing. Thank you, Fembox, for confirming. Okay, 1, 2, 3, 5. Two, 4, 5, 6, 7. Okay, so going from right to left, one that this has nothing to do with, one gets sent to 2. So we start with 2. Well, I guess we start with 1 and then 2. Now one gets sent to 2. Now we plug in 2 to figure out what 2 gets sent to. 2 gets sent to 4. This has nothing to do with 4. So 4. Now we plug 4 in. 4 gets sent to 5. 5 gets sent to 1. So that's the end of that. Oh, well, we need to put a 5, and that's the end of that cycle. And I guess next we can do 3. This has nothing to do with 3. Wait, that's... What? How did I make an oopsie like this? Oh, it's because the last thing that I wrote in that one was bad. 4 gets sent to 5, but then this 5 gets sent to 1. So it actually ends right there. There we go. That's the error. And then if we do 3, that has nothing to do with 3, that 3 gets sent to 5. And then 5 gets sent to 6, and that has nothing to do with 6. 6 gets sent to 7, that has nothing to do with 7. And that's just... 7 gets sent to... Wait. 2. 2 gets sent to 3. And that's the end of the cycle. Okay. God. That's the directory that I wanted to remember. So I'm glad assuming I did it right. They're definitely disjoint though. And the LCM of these is 12. I'm gonna check the answers on this. Well, the second one was also has the same problem. 3, 4, 5, 2, 4, 5. Is that it? It wasn't. Okay. 1 doesn't appear anywhere. 2 gets sent to 4. 4 gets sent to 5. And that's the end. Well, sorry. That's the end of that particular permutation. Wait, sorry. How did I get this? 4 gets sent to 5, 5 gets sent to 4. Wait, if we plug in a 4, we get... No. Oh my god, dude. 4 gets sent to 5, 5 gets sent to 3. 3. 3 does nothing there, 3 gets sent to 4. I think I should be doing it the way that Phobos said. But I think this shouldn't be that as difficult. It shouldn't be as difficult as I'm making it. I just keep messing it up. Okay. 2 gets sent to 4. 4 gets sent to 5. 5 gets sent to 2. That has nothing to do with 2. Okay, so that's just a pair. 3, that has nothing to do with 3. 3 gets sent to 4. 4 gets sent to 5. 5 gets sent to 4. That doesn't make sense. Four should be sending back to 3 by this logic, but it's... I made yet another mistake. Three gets sent to 4. Is this even a valid... Is this one the trickiest of trick questions? Is this an impossible cycle? 2 and 3 are both getting sent to 4. This isn't possible, right? And 5 is getting sent to 2 and 3 at the same time? Or no, 5 is getting sent to just 3? And where am I doing this wrong? 2 gets sent to 5, 5 gets sent to 3. No, sorry, 2 gets sent to 4, 4 gets sent to 5. Three has nothing to do. 3 gets sent to 4. 4 gets sent to 5. 5 gets sent to 4. I need to check the answer key. This one, I think this is maybe not a possible, it's not a valid permutation. Four goes to 5. And 5 goes to 3? We're working from left to right. There's apparently different conventions for Phobos. The book does right to left for these. Oh god, and Joseph, I see that redeem. It is funny, but I might be too tired to draw something that big. Like that's, it's like 6 different people all in a style, I don't think I'm gonna do that. I didn't read the chapter. Sorry, 4 goes to 5 and 5 goes to 3. 4 goes to 5 in this? Because if you give a 4 into this first one sends the 4 to 5, and then you give the 5 to the next one, which goes to 3. Because at least in this book, we're doing it like right to left. 4 gets sent to 5, 5 gets sent to 3. 3 gets sent to 4, 4 gets sent to 5. No. 3 just gets sent to 4. If you give it a 2, it gets sent to 4, that 4 gets sent to 5. You give it a 5, that gets sent to 2. Maybe it is valid then. Okay. The 2 and the 5 I got right. This is so weird to unpack. Four gets sent to 5. 5 gets. I know that I can do this without making the table, but I think I'm still just a little bit too stupid to actually. Do it. I need to get more used to it. So all we're doing is 2 swaps, 2, 5, and 3, 4. Wait, my 4 goes to 5 in the first, and the 5 goes to the 3. What did I write? Oh yeah, okay, I fixed that. I didn't read it, but I managed to fix it on my own, I think. Yeah, Renga. That's the exact thing that I want to use. But the last 2 parts in this are like kind of trick problems where they don't give you disjoint cycles, so you had to make them disjoint. A brain teaser, Navia? This is enough of a brain teaser for me right now, I think. My brain feels thoroughly teased. As it is. Yeah, I just did E and F. So I wrote out their disjoint cycles. I found E is a 3 cycle times a 4 cycle, which means the order is 12, the LCM, and F is 2 2 cycles, so the order is 2. I want to check the answer though. I'm gonna guess page 580. A little bit of scroll. 12 and 2, that's what I said. I forget what I said for the other parts, but those are a lot easier. I didn't know what to think about that question, Navia. Okay, what did Penn Center assign next? Seven. Order of the product of a pair of disjoint cycles of lengths 12. It's a much simpler version of what we were doing up above, I think. But we're given it's disjoint, so. All right, 8. Determine whether the following permutations are even or odd. So even and odd permutations have to do with the number of 2 cycles that these can be expressed as. And you can express this one as 2 cycles, so it should be even. Let's verify, or let's look at what the book says, though. Excited for permutation. Craigasm. Hey, Alvito. Okay, cool. I remembered that right. And okay, what I was wondering is that there's not just one way to express things as a product of 2 cycles, but this theorem says as long as you can find one, all the others must also be even or odd. Or they must, if you find one that's even, everything else has to be even. If you find one that's odd, everything else has to be odd. So back down to number 8. Shame you never worked at Kanye West school, because then it'll be Don does math. What? There's a Kanye joke in there that I've only heard a couple of Kanye songs, so I don't know if there's like a... Oh, it's called the Donda Academy? I didn't know that. That would have been perfect. I would be the department chair, I'm sure. So this one I could write as 1, 3 times 1, 5. So I'm going to say that's even. By the same logic, this is odd, even. These both get split into 2. So we get a length of 5, which is odd. No. 2 is repeated. Oh my god. How do we untangle these? We have 1, 2 and 1, 5, 2. Oh, maybe it doesn't. Yeah, if it's invariant, it's still... I think it does. Or does it? Mocked? Yeah, I was wondering if you would get the same result. I guess you can still do it. Yeah, I guess it's fine. Okay. So you do have a 1, 2 is going to get repeated in there, but that's what the permutation is, I guess. So this one, can we not think about it too hard and just do the same logic that you would get 3 2 cycles from this and 3 2 cycles from that? I guess there's no reason why we can't. So it would be even. Okay. So what are my answers? Oh no, it's an even number problem. I won't be able to check them. Oh well. I'm saying even, odd, even, odd, even. I'm alternating, I guess. Next up is 9. The possible orders for the elements of S6 and A6. What about A7? This is where, well, wait. Orders for the elements of S6, never mind. We have to think about partitions here. The partitions of 6. Right? They did an example, I think, with 7. Yeah, it's kind of weird to think about megamorph. I guess that's the idea that I was getting tripped up on. Disjoint cycles. Okay, yes. Yes. ¿Dónde está Academy? Okay. So if we have 6, now we need all the partitions of 6. So we can do 5 and 1. We can do 4 and 2. We can do 4 and 1 and 1. We can do 3 and 3. We can do 3 and 2 and 1. 3 and 1 and 1. And then I guess we can do 2. Oh God, what I'm just writing gibberish right now. And 2. We can do 2, 2, 1, 1. We can do 2, 1, 1, 1, 1. And we can do 1, 1, 1, 1, 1. Okay, there we go. I think those are partitions. Yeah, I can get the question back up again. Talking about homomorphisms, and it's really useful to think of the sign of partition as a oh, interesting. I mean, hey, Obi, I'm glad you got your computer figured out. I hope your stream was good. The 311? Oh yeah, you're right. I need another 1 there, don't I? Number 9 here. On some more mathematics, teach your problems from NCTM until your windows stop functioning. Worked on some GRE prep questions verbally. That's nice about the computer. At least you were improvising though, or able to improvise. Until we finish talking about until we finish talking about the first question about functions finding domain, which I did on a whiteboard. Nice. That's what I like to hear. We need another 1 here. So then the possible orders for S6. It's going to be the LCM of each of these rows. Which I guess maybe the bottom up is better to work from. So like we can get 1, 2, 3, 6. We also have a 4 and a 5 and a 6. What? That doesn't, that seems, is it because 6 is an even number? We get a lot of nice things. I feel like I did something wrong there. I mean, the LCMs just come out to be 1, 2, 3, 4, 5, 6. That's what I was doing. Oh my god, I keep scrolling while I'm holding control. I'm trying to zoom out and scroll at the same time, but it's just zooming me in. Okay, yeah, we don't get any like weird. 6 is just a small number, I guess, and it's even. So our LCMs aren't particularly interesting. I think I stand by it. It's 1, 2, 3, 4, 5, 6. We do need to do the same thing, but for A6, which is all of the even permutations. Oh, hey, we can just do 6 factorial over 2, though. No, we can't. I have to sneeze. We have to go through the list we just made and eliminate all the odd permutations. Or call the even ones. Thank you, Phoenix. Okay. So if you have a 6 cycle that is disjoint, you can break that out into, I'm going to say 5 2 cycles? Because you would have 1, 2, 3, 4, 5, 6. You would do 1 and 6. 1 is 1, 2, 3, 4, 5. Yeah. So I'm going to say that's odd. This one, you can get 4, and the 1 doesn't even matter. So 5 is possible, I'm going to say. This one, you would get 3 cycles from that, and 1 cycle from that, which means that's even. So 4 is possible. That's odd. This is 2 and 2, which is even. That means it's 4, right? Wait, am I doing this wrong? No, I'm right. Am I right? No, that means these are an even, so their LCM should be included, so it's 3. So I'm counting that as even, that as, wait, was it? Yeah, this one is even. This one is even. This one, 2 and 1 is 3, odd. 2 is even. So actually, yeah, 2 is possible as well. And then we definitely have 1 from that case. That's, oh my god, I can't draw stars. Both these cases down. What? I can't, there we go. If I think hard enough, I'm able to draw stars still. So 2, 3, 4, and 5, I'm saying, for A6. Ugh. Alti, hey! Can't remember why I was trying to program a solution to this sort of problem, kept getting lost in the weeds. Almost code a solution to this problem. I feel like Chat GPT as the answer. Oh wait, what about A7? Let's look at the table they made for S7 and do the same process. I'm gonna guess page 120? No, I'm a little too far back. There we go. Okay, so 7 can get broken out into 6. Cycles, 2 cycles, which means it's even and should be counted. Oh wait, so right, yeah, so that means that 7 would be the LCM, and so 7 is possible. 6, 1 is not possible. I need to write these down. You know how I feel about AI? Oh, I mean, I'm only saying you should use ChatGPT because it's, you know, the problem was code a solution to this problem, you know. That's what I want to spend time on. I don't like ChatGPT or a lot of AI either. It's an A and there'll be an even number of even length cycles, which are actually odd permutations. Oh god. That hurts my head to think about. It's an odd, what? I'm going back to my process here, but I'm getting confused on that. That's 4 plus 1 is 5. That does not count. That's 4, which does count. The LCM of that is 5. That's 3, and that's 2, which is 5, which does not count. This is 3 plus 1 is 4, which does count. The LCM is 4. That's 3. That's 2 and 2. And the LCM is 3, so that counts. That's 2, 1, 1, which does count. So we get 6 in the mix, okay? 2 and 1 is odd. 2 counts, but we already had 3. Odd number doesn't count. Even does count, so 2 is possible. Okay, so for this one, I got every number except for 1, I guess. Wait. Yeah. You probably can't ever get 1, right? For A. 1, 2 is an odd permutation, even though it's a 2 cycle. Oh, just because, or it's an odd permutation. Oh, because it's like order 1, I guess. Oh, okay, yeah. Like if you did the LCM, no. I don't know. This is number 9. I'm gonna check my answer. 600? Oh, right. It's 1 transposition. 1, 2. Like you can. Okay, I was thinking. That's a nice way to think about it. For S6, possible orders are 1, 2, 3, 4, 5, 6. Hell yeah. For A6, 1, 2, 3, 4, 5. I missed the 1. For A7, 1, 2, 3, 4, 5, 6, 7. I missed the 1 again. Okay. So when do you have an even permutation? Oh, 0 is even. Oh my god. Okay. The book might have even talked about that. That the identity is considered even. It's annoying. Okay, that makes sense. Megamorph, for the number of times you need to compose it to get back to the identity. Where the permutation to even is opposite order, the sign has an even number of things in it. Which is weird. Think of are assigned 7 through 11. Let's get 10. Show that A8 contains an element of order 15. Well, because it has disjoint cycles of length 5 and 3. Easy, done. Next question, 11. Find an element in A12 of order 30. Oh wait, I need to verify that 5-3 in number 10. I need to verify that 5-3 is actually in A8. So I was thinking of S8. But if you have a cycle, a 5 cycle has 4 2 pairs, or 2 cycles. A 3 cycle has 2 pairs. So we do get an even number, so it's good in A. Now we need something in A12 of order 30. So, like, 10 and 3 don't work because they don't add to 12. 6 and 5 don't add to 12. Oh, 6, 5, and 1. Is that the trick? But we need to verify the same thing, that it will be in A12. And I don't think it is. Could we do like 5, 3, and 2? 5, 3, 2, and 1. No. Ah. You really can find an AI bro interviewing for a job by asking why you should hire them. And you just prompt the AI by yourself. Ugh. I guess the response probably because they know how to set up the AI and train it, but I don't know. Come H12 of order 30. What else can multiply to 30? We have 10, 3, we have 5, 6. Is that all? I feel like 30 should have more factors, but I don't think it does. That feels wrong. Prompt engineers. Oh, yeah. I haven't heard the title prompt engineer, but I'm sure it exists. A12 of order 30. It has to be something with 5 and 6, but like, well, ooh, can we? So see, 5. If we have 5, 3, 2, 1, 5 can be 4 2 cycles. 3 can be 2 2 cycles. So it's not an A. 12. Is that a quote? Megalomorph? It sounds like a quote. I don't know. First part of Shakespeare? Oh, okay. Hamlet minus a Horatio. I remember being assigned to read Hamlet, and after like my junior year of high school, I couldn't be bothered to read any of the books in English class. So I spark notes my way through the last 2 years of English classes, and I actually did pretty well on the AP test. I think I got like a 4 and a 5. So I feel like I was kind of vindicated. I don't remember. I think the 5 was in my senior year one, the 4 was in junior year. I don't know. But I definitely did not read crap, and I still managed to do well. But that's the an element in A12 of order 30. I feel like it has to be something with 5 and 6, and we can break down the 6 into 3 and 2 if we wanted. But neither of them work is the issue. A 5 was 65%. Oh, really? I didn't know the bar was that low. Wikipedia is saying 70 to I mean, it probably depends on the subject, I guess, in the year. AP pre-calc for some reason. Exceptions to this rule of thumb. Get half of them right, you get a 3. It's not bad. Yeah, I mean, I did pretty well in my AP tests, but I'm also a nerd who probably spent too much time studying. It probably Algebra itself probably isn't gonna put out the exact stuff. But I don't know. New math joke Shakespeare included in his plays. Oh, really? I'll read Shakespeare when Shakespeare updates the language in his books or his plays. It's so like hey, Wisdom Wellness Hub, how's it going? Like, even if I read books that are written relatively recently, I have to read the same paragraph multiple times before I understand it. And with Shakespeare, it's that times 1,000. Like, it's just way denser. What you do about numbers. It just strings together one cliche after. That has to be okay. So that has to be a joke because like Shakespeare is the one who made it, or like he did it before it was a cliche and everyone copied him. I assume that's what the joke is. Okay, I'm glad I at least got that. like the Beatles, I guess. I'm beginning to think there isn't an element in H12 of order 30. Unless you do something like I'm trying to go through all the different partitions of 12 in my head right now, but only certain ones can possibly have an LCM of 30. Like they have to be a factor of 30, which leaves you only with 10, 3, and 5 and 6. And 10 and 3 doesn't add to 12, and 5 and 6 just don't work. Is this a trick question? I'm about to check the answer key here. A 5 and a 6. I agree, Renga. Okay, before let's back up since before I check the answer. One, two, three, four, five, 6, 7, 8, 9, 10 has order 30, but it's not an A12. Yeah. But we can't mess with like the lengths of the 5, the 3, and the 2 without messing up the LCM, which is why I feel like this can't be done. Like, I can't think of a way to force that to be an A12. Be added disjoint 2, 3, or 5 cycle without changing the LCM. Oh. Wait, a 5, a 3, and a 2. Well, the issue there is that 5, 3, and 2 adds to 11. So you can only add on a 1 cycle, can you not? Or wait, am I undercounting by 1? 5 plus... Oh my god. I can't do math. Oh, I would have... the entire time I was thinking that it added to 6. I've known the idea then. Or added to 11. Oh my god. So yeah, we just add on any two cycle we want, and the LCM is the same, and it goes in A12. I just thought that I think about how I started with 5 and 6, which adds to 11, and I forgot that if you break the 6 down into 3 and 2, that's now a 5, and 5 plus 5 is 10. Okay, thank you, Hooper. Ugh. Okay. Someone's posted in my Discord. Is it a? Oh, okay, it's an answer to the question I couldn't do. Let's do like 1 or 2 more algebra problems, then I might call it for the day. Oh, 17 is next. No. 14. I don't know. I looked right at the one I didn't want to do, but no, 14 through 16. Penn Center strategically avoided 17. Okay. Coding contract in Bitburner, game I was playing. Given a number, how many different distinct ways written as the sum of at least 2 positive integers? Oh, nice. I know for Project Euler, I've tried to do a similar problem. They're talking about every partition, though, which is like potentially more than 2 positive integers. If it's just 2 positive integers, that seems like you just keep subtracting 1 from your total or something. Oh yeah, I mean, it's probably easier to do that. I mean, I don't even know if abstract algebra can probably help, but I don't know how. I never taken an abstract algebra class, so this is all new for me. Remember when you teach second grade addition, you say you can't just forget this because you use it for other things in the future. This true. We're doing 14. Potentially 14, or Penthener's cut out 14 through 16. I don't know if we'll do, depending on how long they take, we'll see if we can do this set of questions here. Charts end up looking like yours. 7, 6 plus 1. Oh, yeah, that's fair. Getting getting a partition for an arbitrary number, I think there must be an algorithm for it somewhere to do with coding, but I was having a hard time figuring out when I was trying like months ago. I feel like something you can maybe do recursively or something, but I don't know. Suppose alpha is a 6 cycle, beta is a 5 cycle. Determine whether this thing is even or odd. Oh, geez. What happens if you raise a cycle to a power? You're really just shifting. You don't actually get a new order, right? Penn Center did. Yeah, I get lost in trying to write recursive programs. I used to know how it worked better, but I've forgotten it now. Penn Center is the one who's actually like running this reading group. I've just been like falling behind slowly over the last like month or two. So I'm just doing the E&M thing too and all that stuff. So to an odd power, it's the same sign. Really? I don't think we learned that from the book. I wonder if they intend you to figure that out for yourself. Because I don't think they ever talked about raising a cycle to a power like this. What could be the rationale for that? If you have an even cycle, Yeah, like if it's a 6 cycle, they don't say disjoint. Yeah, I think it's a good direction. Well, a cycle, it can't repeat itself anyway. We don't have to care about. Yeah, never mind. A 6 cycle, you can break it down into 5 2 cycles. And so if you take those 5 2 cycles and square them, you get 10 2 cycles. 10. Yes, no, 10. No? Yes, 10. If you cube them, you get 15, which is back to odd. Cube to the 4th, you get even. Right, so an even power makes it even, an odd power keeps it odd, at least for that example with 5 that we looked at. Now, if we have a 5 cycle, which would be 4 2 cycles, no matter what you do, that should just always be even, because you'll get 4, then 8, then 12. Okay. Okay. Even times it. Yeah, right. Now, how does the inverse affect it? I feel like inverse should preserve even or oddness. If you have a bunch of transpositions, could you just reverse the order of those transpositions? But it's still the same number. Yeah, yeah, okay. Okay, yeah. So alpha is a 6 cycle, which means it has 5 2 cycles. And 5 to the 5 is odd. So we have an odd thing times an even thing is even times. As soon as one thing is even, isn't it always going to be even? Do we even have to bother with the. As soon as we have one even thing. Wait. Are we doing addition or multiplication? It's important, right? We're doing addition. So it's not as simple as I was making it. Okay, so we have an odd plus an even. Not times, because that'll make it way too easy. An odd plus an even is odd. Plus an odd becomes even. An even plus an odd is odd. An odd plus an even is odd. So my final answer is odd, I think. Wait, does it matter? No, left to right or right to left doesn't matter. It's in and 14 is even, so we don't. I don't get to check the answer. I could Google it. The author of the book was on Numberphile recently. It's odd. Oh, hell yeah, $10. Thank you. People use from the giant battle beginning of Henry V. Since a crooked figure, one may test in little place a million, and let us. I would have to read that so many more times before I understand what it's saying. That's my problem with Shakespeare. I don't even know. All right, let's get 15. Let n be positive integer. If n is odd, is an n cycle an odd or an even permutation? I feel like they should have asked this question way earlier. Because I've been using this in my head the entire time. If n is odd, then the n cycle is even. If n is even, then the n cycle is odd. Sometimes on stage attempting to be a million men in a battle. You just don't get it either because they don't understand the mathematical context. Oh. All right. To read annotated version of Shakespeare makes sense without an explanation. Often enough it does not. Yeah, for sure. All right, so let's wrap up with 16, I think. If alpha is even, prove that alpha inverse is even. Oh, okay, well, I think we already said the idea, like, you just bring it into 2 cycles, and all you do to invert that is reverse the order. Okay, well, I feel like that's... Me verbally saying that is enough proof for my standards, at least. Used to like reading your parents' huge Shakespeare book along with the plays when they were on TV when I was a teenager. Oh, really? Yeah, I know my grandma was super into like Shakespeare and literature. And would visit London a lot and do some kind of Shakespeare thing there. Shakespeare's time couldn't understand him either since he was making up words left and right. Oh. The new book that was popular by the book of arithmetic. Oh. Okay. Mel Gibson, Hamlet was great. Oh, I just certainly haven't seen it. Okay, since 16 was so short, maybe we'll do one more. 19 is next. Alpha beta belong to Sn. Prove that alpha beta is even if and only if alpha and beta are both even or both odd. Aw, this is, you just bring it to 2 cycles again. This is a realization I had earlier. That I feel like I need to flip. It's because if alpha and beta are both even, yeah, no, I looked at 16 also. with both of these, just look at the 2 cycles. Rosencrantz and Guildenstern are dead. Yeah, I'd never heard of these. It has to do where if you bring alpha and beta into their 2 cycles, which means you're basically adding the number of 2 cycles, and the only way to get an even number from addition is to start with an even plus an even, or an odd plus an odd. Okay, I feel like I've had like 3 last abstract algebra questions, so maybe I'll make that my actual last one and wrap things up here. Is there anyone streaming math though? I know that Pensacon's gonna have the class in like an hour, but I don't want to go for another hour. Oh, gold is on. When did gold start? I hope he's not about to end. Oh, good. He didn't start that long ago. Okay. I'm gonna wrap things up here for the day, I think. If you're on YouTube, I appreciate you. I'll be back on YouTube on Thursday. That's the day. Bye, YouTube.